Thank you for having me here. I thought it would be nice in this short presentation to look at a few things that happened with Lustre first. So is the microphone working? Yeah. Lustre is a little older, I think, than many people know. This was started in late 1998. And it took until 2002 to get the first production environment. But in 2004, it ran on the #1 computer, which was the Blue Gene computer. And in 2007, it ran on 9 of the 10 top computers. So it was a very fast race. And since then, a lot has happened. And I thought it would be nice to think a little bit about that for a few moments. I don't really work on Lustre very much, but I still work quite a lot in the storage community to speak with big efforts and advise some people. I do the sort of grey hair work, not the real work. Yeah, and so I wanted to go over some of the developments that I think will be happening both with Lustre and both with new systems in the future. I have still some activity in storage, but I have mostly worked on other parallel computing projects, primarily on a big radio telescope the last 5 years, in which Japan is a partner. It is the Square Kilometer Array telescope, which needs a phenomenally large computer, but only in 2025. I/O is not the biggest problem for that computer. Good, so let's have a look at Lustre. So I wanted to, first of all, just summarize a few thoughts about this. So in this history, Lustre delivered, I think, interesting work to many hundreds of people. There are some developers, there are people that sell it, people that install it. It's become quite a significant group in the world that had to do this. Lustre, because it was open, also supplied business to dozens of companies. Yeah, and really, I think on a fairly equal basis, everybody could take it, but only a few really succeeded. Yeah? I think at the moment maybe DDN, Intel, Cray, Fujitsu, yeah, they are the leaders. There are many others, yeah, but it is not so easy to succeed with it. But still, there have been dozens of companies, and I think that the Lustre community should be very proud that it built a cornerstone for HPC. Yeah, this is one of the most used packages, and it's really wonderful. So this has taken an enormous commitment, because this was not easy. It was it didn't work very well for a while. It's complicated, and I hope that everybody I list here, both the users and the developers and the business, that everybody feels a sense of satisfaction. Yeah, this has been a very meaningful effort, I think, in everybody's life, and I think it has gone far beyond my wildest dreams. So thank you very much. Yeah, it's been very, very nice to work on it. So let's look next at what wasn't really done and what could have been done. So Lustre has object storage servers, yeah, and we had those in 1999. They could have been the foundation of the cloud. Yeah, these object storage servers that we have, they are excellent. They're much faster than the ones you find in the cloud, but that didn't happen. The metadata approach was very traditional. It has improved in the last few years, but even the design in 1999 and 2000 was more advanced than what is there now today, and that also didn't happen. But the very interesting thing is that this was a very clear directive. The United States laboratories, which pushed this product in the beginning, they told me very clearly, they said, we don't want Lustre, we want Lustre Light, and we want Lustre Light next year. That was a bit of a mistake, yeah, it took 3 years, yeah, but it still came much quicker, and it is very, very good, perhaps, that we didn't get into all these distractions, because that focus, I think, was essential to the success. There were also a few missed opportunities that I want to call out. So, in my opinion, we should have done a complete rewrite of Lustre, maybe around 2007, 2008. The reason is that at that point, the success was totally clear. Yeah, we had conquered most of the big computers in the world, and a total rewrite, perhaps in a modern programming language, perhaps with user space servers, would have almost certainly led to a much more maintainable code base and ultimately a much lower cost. Because even today, when I look at a new Lustre release, bug fixes are numerous. Yeah, and I think that at some point we could have done a refresh. The other thing that didn't happen because there was no rewrite is that we missed out on a few very basic components, such as the idea of containers. Yeah, containers have become very, very important. I will talk about that more. And they didn't enter the Lustre picture, and that could have been done if we'd done a rewrite. Now, another missed opportunity is the usability. So the usability has been quite bad, and I regret to say that I think it's still very bad. Yeah, it works now, but the manuals are poor. The tuning is very difficult. If you read the Lustre Discuss mailing list, you have some kind of non-standard network maybe. Nobody knows how to do it. And only the very highly skilled vendors that I mentioned earlier can deliver the successful systems. Yeah, it did not become a kitchen product that everybody could install. So these were missed opportunities, you know, not something to regret, but something to think about, maybe. Good, so this is actually all I wanted to say. Again, it's been a great pleasure, and I hope it has been a pleasure for everybody here to be involved in this in one form or another. The remainder of this talk, I wanted to quickly go over a few ideas of the future of storage. I've given this talk in different forms several times over the last year. And so the first thing is that there is a dramatic new storage hardware technology coming. And this table here summarizes, for example, that there is new high bandwidth memory that is suddenly 10 times faster than what we had only a few years ago. NV RAM and Crosspoint, Crosspoint being an example, is suddenly there. It was talked about for a long time, yeah, and this brings totally new parameters to storage that are very unexpected. And flash and disk and tape are, of course, known qualities. If you look at this table, the cost of bandwidth goes up 4 orders of magnitude when you go to tape. The cost of capacity goes down 4 orders of magnitude. This leads to many important questions, namely, what mix of memory and storage devices should you really use? And to give you 2 examples here, you get an important point in the history was when the cost of disk for bandwidth became higher than the cost for flash and bandwidth. And so around 2013, the flash cache became very important. Yeah, and there are products for that. Some people maybe just use it with Lustre, but there are many, many new products for that. So there's a birth of a flash cache. There is another birth coming. The pregnancy is very long. Yeah, it's like another 6 years or something. But in around 2022, the disk capacity cost will become higher than the solid state capacity cost. And so we will have another big transformation in architectures. At the top, there are a few of these little model formulas, and I think many different economic models should be worked on. Not many people are thinking about this, but this will underlie new architectures for new systems. So the next thing I briefly want to look at is a set of the big US deployments, the ones that have happened and the ones that are going to happen. Yeah, there are a few here that I think are in progress. I have only public information about this that people told me, so no secrets here on the slide. So on the left side, I broke it into two periods, roughly 2000 to 2014. So that's only just passed. So in that time frame, we had what I call server-centric storage, with boxes with disks and some flash, and then these formed the storage subsystem with servers. And Lustre and GPHS became quite successful systems, and this delivered a terabyte per second and many petabytes of storage towards 2014. Now, at that point, this first economic change took place, and the flash caches came, and the systems started to become much more complicated. So, for example, new systems came into play that worked together with Lustre often, like the DDN IME, the memory engine for flash systems essentially, and Cray has a somewhat similar product. And in many cases, multiple storage systems were used at the same time, so both flash and disk systems, and that is something that we're going to continue to see. I showed you how many different storage systems there are, so there will be lots of heterogeneous installations in the future. There are other interesting things that happened around this time. Chips started to increasingly come with accelerators, and so Intel very quickly developed a Lustre client for the Knights Landing, Knightsbridge, and I don't know, all these Knights families. So a special client to access the file system directly from the accelerated cores. That still doesn't exist for the GPUs, by the way, yeah, and it's a problem that it doesn't exist for the GPUs. If we look forward, we're going to see more client-centric storage. So the first system I want to mention is a large capability system for nuclear weapon simulation at Los Alamos that will be arriving around 2020. I do not know who will deliver it. I don't know even exactly where it is at, but I had a long discussion about it. Every compute node in that system will become probably a Lustre server. It could become a GPFS server, but it's likely a Lustre server. It will likely have ZFS on something like 10,000 flash nodes. Yeah, 10,000 compute nodes. This system is going to achieve a bandwidth of 100 terabytes per second, perhaps. Yeah, this is almost unbelievable. But this was a dream I had for a very long time. I remember telling many people, if only all the clients could use that bandwidth and not just the servers, yeah, then we would get a much faster system. Again here, there will be a secondary, slower system, maybe with longer retention period, because the economics would make it very expensive to have all that storage in flash. Yeah, so there will be a slower system. Maybe it will still be disk in 2020, that's quite likely. So in 2023, the United States expect to have exascale systems. There was a request for I think, almost request for proposals released just a few weeks ago. And in that case, the architecture is going to change only a little bit, but still quite dramatic. There will perhaps be a new storage system. This might be the end of the way moving forward with Lustre. An object store is a likely candidate to run, in this case, not on flash anymore, but on the order of 10,000 NV RAM devices. And I think that within 10 years, we're going to see a petabyte per second of bandwidth coming from a system like this. In this case, the secondary system with larger capacity may very well be a flash system. Yeah? If you start searching a little bit for on the US labs, you will find more expectations along these lines. So let's look a little bit at what happened with using these systems, because interesting things happened since this evolution started. So cluster file systems have terrible performance problems. Nobody knew this until around 2004, 2005. And a good example that you see here is relatively recent from the Chinese Tianhe computer, maybe 3-4 years ago. The blue bars are what is actually achieved, and a highly optimized version, as you can see, is probably 10-20 times faster. So the efficiency is 5% of your file system, and this is very common. The benchmarks that are shown are almost usually irrelevant. Yeah? The only way to get these high performance numbers really to come out is to start using specialized I/O libraries. And one of the first libraries that established that was called a DIOS. It is not one that became very widely known, but it was a very successful small project done by a small group of very smart people. I have nothing to do with it, by the way. And it does very simple things. It avoids the sort of problem that you see at the top. Two processes going to the same block, yeah? The overlapping stripe issue that many people know about. And the DIOS library showed that if you don't do that, you're much better off. So I will skip the slide, but it's in the deck if you want to read it. Another thing that is happening very, very solidly now is that a choice has been made for storing structured data with a similar kind of library called HDF5. And for a while there was uncertainty whether it would be HDF5 or NetCDF or some new variant, but HDF5 is really winning. And it allows you not only to store arrays with numbers, which is very important in most simulations, but also more complex structures such as key value stores. And it has a surprisingly small overlap with cloud systems for the same purpose. So in the cloud, Google developed Bigtable, and there are endlessly many key value stores, and somehow HDF5 is a very different system that is needed for research computing. Beautiful is that many other formats, particularly NetCDF, have started to leverage HDF5. It's also very beautiful that HDF5 has begun to use very sophisticated lower layers, for example, DIOS. Yeah, the initial HDF5 implementations were maybe not good enough. A big desire for Lustre is to still get a very good HDF5 implementation with Lustre. To my knowledge, this does not exist at the moment. Yeah? And given that HDF5 is the direction of the future, I think that this is an important message I can leave you here. There is new I/O software coming that is still being thought about and under development. I don't have a lot of time here. I could talk about this obviously for days and days, but I brought two pieces along that I thought I should quickly tell you about. So one is a project that you've probably heard of. It's a project that is led by Intel called DIOS, and it is just like Lustre, a collaboration of the Department of Energy, in this case Intel, yeah, not Cluster File Systems or not another storage vendor, and the HDF5 group. And there have been two phases in this project. In 2012 to roughly 2015, an initial prototype was developed that was still based on Lustre and ZFS. And now a second pre-production system is being built that is more focused on NVM. This system is a low-level transactional storage system. It allows groups of applications to collaborate. So it's a very different object store than the sort of object store you find in Amazon. it is intended to scale to hundreds of thousands of servers and a billion processes. Yeah, so its application will not be directly for end users, but likely it will support HDF5 and maybe some new file systems. Yeah, I suspect it will be a little bit difficult to use it directly, although it's not too bad. A second system, or a second new storage system, not one system, a family of systems, are really the role of containers. So I mentioned early on how there are now many tiers of storage that have a fast side and a slow side. And the right way to deal with this is to allow a system like a container to have very fast updates on one side, but the possibility to stream out more slowly to the other side. Yeah, because slow, big I/O is easier to do than fine-grained, fast I/O. This continues to escape implementation. So this has been brought up many, many times. I remember giving talks about this as early as 2008 and 9, and it was part of DEOS, but it isn't really implemented in DEOS yet. And I think these container systems will become very, very important. Again, these are different containers than the Kubernetes and Dockers and so on. The HPC world is a little bit different. Let me quickly wrap up with a few challenges and conclusions here. So, the key challenge for the new systems is a big contrast with what happened in 2000. So in 2000 we started to build cluster file systems, and everybody said they have to be POSIX systems. And that was incredibly helpful because POSIX is very well defined, everybody knows what it is. And now, with the new systems, there are new APIs. And these new APIs are open for discussion, there are no standards, and it will be a very difficult road to convince all applications to pick up something new like this. On the other hand, POSIX is going to hit a brick wall with the very fast storage devices that are going to come. The second challenge is a big difference in deployment. So deployment in HPC really has to start looking more like the cloud. The cloud is characterized to me by two important facts. One, it works. Yeah, this is not always the case, as you probably know, with other storage systems. Yeah, they don't always work. Secondly, they're cheap. And meeting this challenge is going to be a big issue, I think, going forward. So, beauty and simplicity are actually lying ahead of us, because I think the DEOS system is a beautiful idea of how processes should work together. It has been proven by some of the other things I mentioned, like the DEOS and HDF5. They are closely related at the level of concepts. So that is very, very nice. Yeah? There are, on the other hand, a lot of challenges that must be overcome to get these systems to a level of success like Lustre. So, for example, unfortunately, DEOS still doesn't have a customer. Yeah, and it is about time we get one, in my opinion, because that helps. Above all, I have to say, the hardware developments have been fantastic. Yeah, who would have thought that we would have 4 orders of magnitude improvement in storage hardware in the last 10 years? It's really a very exciting time to work on this. I want to leave it at this. Thank you very much.
Peter Braam 博士、ありがとうございました。Thank you very much.